the second fundamental rule in electronics stated by Gustav Kirchhoff, which is Kirchhoff voltage law, which is also known as Kirchhoff second law or Kirchhoff loop law. KVL is nothing but it deals with the voltage source in a closed loop or a closed circuit. So KVL saying that the algebraic sum of all the voltages in any closed loop is equal to 0. So this is KVL basically. So let's consider one circuit. For example, consider this electrical circuit which contains voltage source V and three passive components. Z1, Z2, Z3 are the three passive components. These could be a resistor, capacitor or inductor something. And let's consider the current flowing through this circuit is in clockwise direction. So we know that according to sign convention, so what is sign convention is saying? Sign convention means when we are moving from negative to positive terminal across any element or any component, which means it's a rise. So we will take that voltage as positive voltage. Similarly, if we are moving from positive to negative, we will say it is a drop. So we will consider the voltage as negative. So in this circuit also we will use the same sign convention. So here I am considering this is positive because the battery, the voltage source indicating this side is a positive side. So I am applying positive and this will become negative. Here this will become positive, negative, positive and negative. And we know one thing, whenever current flowing through a circuit, current I, let's consider the current I is flowing through the circuit. If it is passing through a passive component, there will be a voltage drop. So these passive components are connected in series. So similar current only will flow, the same current only will flow through this entire circuitry. So in Z1, voltage drop will happen because of this passive component. Let's consider the voltage drop as V1. Similarly for Z2, V2 and Z3 as V3. So according to Ohm's law, we can write all the voltage equals to 0. Sum of all the voltage across a closed loop. It's a closed loop, right? So all the closed loop, it will be 0. So we can say V. Let's consider V as a positive one because negative to positive only. So it's a positive voltage. V equal to or V plus, here positive to negative it is going. So we will consider this as a negative voltage drop. So minus V1 plus, here also positive to negative only it is going. So this is also will be minus V2 plus, here also positive to negative. So it will be minus V3, which is equal to 0. So we can say that V minus V1 minus V2 minus V3 equal to 0. From this equation we can say the voltage, applied voltage is equal to V1 plus V2 plus V3. So here we can see, in any closed loop, the total voltage in the closed loop is equal to the sum of individual voltage in that loop. So, or we can say, in any closed loop or network, the total voltage around the loop is equal to the sum of all voltage drop. These are the voltage drop, right, within the same loop. So this is what is Kirchhoff voltage law. Let's consider this equation as equation number 1. We can define the voltage as in terms of energy, that is V equal to E by Q, which means that the energy required by unit charge or the energy required to move a unit charge. So let's put this equation in equation number 1. So equation number 1 becomes E by Q equal to E1 by Q plus E2 by Q plus E3 by Q. So it will become E equal to E1 plus E2 plus E3. So here you can see that the energy supplied by the voltage source is equal to the energy dissipated across three passive components E1, E2 and E3 respectively. So we can say that the energy supplied by the voltage source in the circuit is equal to the energy consumed by the passive component in the circuit. So KVL is nothing but, we can say, law of conservation of energy. Let's consider this closed circuit which is having two voltage sources providing 5 volt and 2 volt, and we have three resistance which is having 5 ohm, 10 ohm and 15 ohm resistance respectively. So we have to find the current flowing through this closed loop and the voltage drop across the resistor 15 ohm. So how we can find out this? By applying KVL. Let's see. So I am considering the voltage drop across 5 ohm is V1 and 10 ohm is V2, and let's take V3 as the voltage drop across 15 ohm resistance. And I am considering that the current is flowing through a closed loop. And we know that I am considering the current is I. These components are connected in series. So the current flowing through the entire circuit will be the same. So according to KVL, we know that KVL is saying that the algebraic sum of all the current is equal to, so all the voltage is equal to 0. So we know that, let's consider this is positive and this is negative, this is positive, negative, and this will become positive and negative. So by applying KVL, we can write the sum of voltage in the closed loop is 5 volt plus, we know that according to sign convention, this is from plus to minus it is going, so it will become minus V1 plus, here also plus to minus only it is moving, so minus V2. Similarly this voltage plus to minus only, so minus 2 volt plus minus V3 which is equal to 0. So we can say that 3 volt is equal to V1 plus V2 plus V3. Let's take this as equation number 1. So We know that according to Ohm's law, V equal to I into R. So we can say the voltage drop across 5 ohm resistance, that is V1, which is equal to current I into resistance 5, that is 5I. Similarly, voltage drop V2 across resistor 10 ohm become 10 into current, which is same only, so 10I. Similarly, V3 becomes 15I. So let's put these V1, V2, V3 values in equation number 1. So equation number 1 becomes 3 volt or 3 is equal to V1. What is the value of V1? It is 5I. 5I plus 10I plus 15I. So we will get 3 is equal to 30I. Therefore, I will become 3 by 13, which means 0.1 ampere. So we got the current value of this closed loop. So now what we have to find? We find the current flowing through this closed path. Similarly, we have to find the voltage drop across this 15 ohm resistance, that is V3. So we already got the equation of V3 following Ohm's law. So V3 is equal to 15 into I. So 15 into 0.1, which is equal to 1.5 volt. So in this way, by applying KVL, we can find the current and voltage in any electrical circuit or in any electrical components. So let's consider another example also. Let's consider this example, which is having two voltage sources providing 10 volt and 20 volt respectively, and we have three resistors 20, 10 and 30 ohms, and V1, V2, V3 are the voltage drop across the resistors, and I1 is the current flowing through this circuit, and I consider the current is flowing through a clockwise direction. So by applying KVL, we can write 10 volt. I am not marking the sign convention here, plus V1 become minus V1 because it is going positive to negative, plus minus V2 plus minus 20 volt plus minus V3 equal to 0. So here we have to find the voltage drop across the three resistance, that is V1, V2, V3, and the current flowing through this closed loop, that is I1. We have to find these four. So let's consider this equation as equation number 1. We know that Ohm's law, according to Ohm's law, V equal to I into R. So applying the values of voltage here in this equation number 1, so 10 minus voltage V1. V1 means the voltage drop across 20 ohm. So 20 into I into R, right? So we know the value of resistance and current also. So 20 into I1 minus V2, voltage drop across 10 ohm. So 10 into I1. The components are connected in series, so the current values is also same, minus 20 minus 30 I1, so which is V3 equal to 0. So we can write minus 10 minus 60 I1 equal to 0. So I1 is equal to minus 10 by 60. So which means minus 0.16 ampere. So here we got negative sign, which indicates what we assume. We assume the current direction in clockwise. Actually, here the current direction is opposite what we assume. So it is flowing anti-clockwise. That's why we got negative symbol. So the current is flowing is just opposite we assumed. So we got the current value. So it is easy to find the voltage drop across this resistance. So let's consider V1. Let's find V1, which is the voltage drop across 20 ohm resistance. So according to Ohm's law, we know that 20 into I1 is the value of V1. So we know that value of I1 is 0.166. So 20 into 0.166, it's almost 3.3 volt we will get. Similarly, V2, which is voltage drop across 10 ohm resistance. So 10 into 0.166. So 1.66 volt we will get. Finally, we have to find V3, which is the voltage drop across the resistance 30 ohm. So 0.16 into 30. So we got 5.0. So like this we can find the individual voltage drop or the total voltage, or we can find the current and voltage in any electrical circuit.